Hello everyone, today I will be presenting our recent work on an integrated approach to represent and adapt human collaborative tasks. As cobots are becoming integrated to human environments where non-expert users need to collaborate with them, the demand to provide an efficient framework that makes cobots collaborative and adaptive is increasing. Such framework also should make users able to easily operate with cobots and train them. In our work, we design and develop a framework that allows us to integrate human-robot collaboration with training methods. Our approach provides andrograph-based models for both collaboration and training tasks. It also allows human operators to intervene and interactively switch between collaborative and training modes. And ultimately, we describe an integrated collaboration and kinesthetic teaching scenario and validate it in a real-world robotic scenario. In our approach, we adopted andrographs to model both robot collaboration and kinesthetic teaching methods. You can see an instance of such graph in the figure. The left side figure is a normal graph that is used to model collaboration tasks, while the right side of the figure, the branch graph, is created by human intervention and used for kinesthetic teaching. In general, an andrograph is a graph that represents a problem-solving process. Achieving the goal in andrograph means traversing from leaf nodes to the root node of the graph. The main components of andrographs are states and hyperarcs. Each state represents a collaboration or teaching step, and each hyperarc represents a transitioning among the states. The relation among child nodes is the logical AND, and the relation between different hyperarcs are logical OR. The overall architecture of the framework is depicted in this figure. The architecture embeds three main layers, namely perception in green color that is responsible for capturing human activities and also inspecting products effects status. The representation layer in blue is composed of Andor tree, where the tree of graphs are created. Tree search, which is responsible for solving the tree, and knowledge base which is used to store data. The action layer in red has two main components, where task and motion planning interface maps high-level tasks to low-level motions, and the motion planner is responsible for planning and executing low-level motions. To evaluate our approach, we performed some experiments. In this experiment that you see in the video, the robot is supposed to collaboratively with human operator inspect the defect of objects, classify them, and place them into their corresponding boxes. The, the inspection scenario is done through an andrograph, and robot has to traverse a collaborative andrograph to achieve this goal. Human operator, by raising his left arm, intervenes in some cases and creates a branch teaching graph and starts teaching robot arms the position of objects to pick, the handover positions, and also the position of boxes that robot has to place the faulty and non-faulty objects. In this work, we presented an integrated framework to target both human-robot collaboration and kinesthetic teaching methods. The framework embeds andrographs for task-level plannings. And finally, we validated our framework in a real-world scenario, robotic scenario. Thanks for watching.